now we're going to talk a bit about these conformational isomers or conformations. And I'm going to start section 4.2 with conformations of alkanes and similar compounds. That means compounds containing only single bonds, singly bonded groups attached. I'm going to start with ethane. It's a nice simple case. It's getting close to midnight and I've been here for 16 hours now, so I may be pretty tired. So I'll just stick to fairly simple compounds, I think. So imagine we have ethane is the simplest alkane that has a carbon-carbon bond, and I've got a molecule here that's supposed to represent ethane, and it's just two methyl groups joined together, really. So imagine that we're looking from end on at the molecule like this, and I'm going to try and draw this in some different ways. And my old physics teacher in my high school used to always draw these little eyes to show a particular viewpoint. So I'm going to copy his style, and imagine we're looking end on along the molecule, and it's arranged like this. We'd see something might look something like this. So we're looking at it like this. And so the back hydrogens really, they're kind of partly blocked by the front hydrogens, but for the drawing we want to be able to see them in place, so this is what we call a Newman projection. And it's a very useful way to see the spatial arrangement of atoms. We can see in the drawing really two types of CH bond. So the front ones are drawn like they have a spoke going all the way to the middle, because if it's on the front, we can sort of see that. But the ones that are behind, we draw slightly differently. So they're on the back carbon, so those refer to this one, and this one. So here you can see, as we look along the bond, the H's are all aligned with each other, and we call that an eclipsed form. Or an eclipsed conformation. Now, we can also have, now if we've got free rotation, we can actually in effect have an infinite number of conformations, I suppose, but we want to focus on ones that have a distinctive structure. So the other and most obvious one is where the H's are what we call staggered, meaning the H's at the back come right between the H's at the front. So we have a structure more like that. And I'll try and not get in the way of it. So if we have a structure like that, now our side view is our eye, again looking down the molecule. We're going to have, actually let me, we may have the front one still the same way. But now the right-hand carbon, which is the back carbon, that now has the H's organized differently. Now one that's in the same plane as the carbon-carbon bond is going down. Now if we draw a Newman projection for this, front H's are still the same, but the back H's are 60 degrees skewed from the front ones. So that gives us then this staggered form.